So let's start with introduction. What is differentiation? Differentiation is a method that used to compute the rate of change of a function fx with respect to its input x. Other than that, to solve the maximum and minimum values. Introduction technique of differentiation. First, we got power rules used for function of the form fx equal to x power n. Second, we got product rules used when differentiation the product of two functions. Third, we got quotient rule used for division of two functions. And lastly, chain rule used for composite function like function inside other function. You can see the formula at right side. We got two techniques of differentiation in calculus. First, we got implicate differentiation is used when a function is not explicitly solved for one variable. For example, x power 2 plus y power 2 equal 1. For second, algorithmic differentiation is useful for function involving products, coefficient, or powers of function. It also involves taking the natural log of both sides before differentiating.
For question 1, explain the meaning of differentiation and what are the techniques of differentiation. So, first title of the topic is Technique of Differentiation. An introduction of the topic is differentiation is a fundamental concept in calculus used to find the rate of change of a function. In calculus, there are several techniques of differentiation. One of the most basic techniques is a power rule, which is used to differentiate function involving powers of x. So, the answer for question 1 is the derivative dy over dx represent the gradient of the tangent line to the curve y equals to fx at the specific point. Formula for this question is f prime x equals to lim h to 0 open bracket x plus h plus close bracket minus 2fx divide h. So for question 2, find dy over dx for 7x to the power of 4 tan in bracket x square plus 3. So title of the topic is Technique and Differentiation, Product Rule with Chain Rule. So introduction of the topic, when function is formed by multiplying two functions together, the power rule alone is not sufficient. In such case, the power rule is used if one of the function contains another function inside it. The chain rule is also required. So for the solution is, first we need to identify the rule. So product rule formula is dy over dx equals to u prime v plus u v prime. And then we need to define u and v. U equals to 7x to the power of 4. V equals to tan in bracket x square plus 3. So next we need to differentiate. So for differentiate, we have u prime equals to 20x x cubed and v prime equals to sec square in bracket x square plus 3 multiple 2x using chain rule. So next we need to apply product rule. So for product rule is dy over dx equals to 20x x cubed tan in bracket x square plus 3 plus 7x to the power of 4 in bracket 2x sec square in bracket x square plus 3. So after we apply product rule, we need to simplify all of it. So we got dy over dx equals to 14x cubed in bracket 2 tan in bracket x square plus 3 plus x square sec square in bracket x square plus 3. So that was the final answer.
So for the next question, question number 3, we will try to take a look at the example question that require implicit differentiation to solve. So for this one, given y power of 2 and 7x minus e power of 2 minus x minus second 4y equals 0. This previous equation, find the dy dx using the implicit differentiation. So if we take a look at this equation right here, it is a bit complex to solve using one isolation directly. So that is where the implicit differentiation comes in. It's a calculus technique for finding derivatives of equation, where the y is in a species of both of x, using the chain rules of the y term, differentiation both sides of the equation, and then we're solving for dy dx. So basically, so to put it simply, if we implicit differentiation requires like four fundamental steps: derivation or differentiation, isolation, factor dy dx, and then performing division. So let's look at how will be done. First, we take the given equation and then write it in terms of d dx. So this will be d dx, open bracket y power of 2 ln 7x minus e power of 2 minus x minus secant for y close bracket equals 0 d dx. So from this equation, we can now apply the many of the rules for derivation. So first we take the y power of 2 and 7x and apply product rule to become y power of 2 1x plus 2y and 7x dy dx. And then next we take the negative if power of 2 minus x, then apply chain rule to become the plus e power of 2 minus x. We do the same too with the negative secant for y, apply chain rule to become the negative 4 secant for y, tangent for y, dy dx. And then we bring the 0 to the bottom to become equal 0. So that's a derivation step. Next we need to isolate the dy dx with the rest of the normal equation. So we take the plus e power of 2 minus x and move it to the right side. And then we take y power of 2, 1 per x and move it to the right side. So it will become 2y and 7x dy dx minus 4 secant 4y. Tangent for y dy dx equals negative e power of 2 negative x minus y power of 2, 1 per x. So from here we need to factorize all of this new equation with the term of dy dx. So we do just that, and it will become dy dx, open bracket 2y and 7x, minus 4 secant 4y tangent for y, close bracket, equals negative e power of 2 minus x, minus 1 power of 2, 1 per x. So now with all this has been done, we can now apply the division to cancel out the left side. So 2y and 7x minus 4 secant 4y tangent 4y divided by itself, and then on the right side we take negative e power of 2 minus x minus y power of 2, 1 per x, divide with the equation of the left side. So performing division and cancellation later, we should get the dy dx equals negative e power of 2 minus x minus y power of 2, 1 per x, or 2y and 7x minus 4 secant 4y tangent 4y, and then this is the final answer.
For question 4, use linear approximation to estimate the value of square root 63.99 minus with 1 over square root 63.99. Step 1. Let x equal to 63.99 and x0 equal to 64. After that, I define the function fx and f prime x. For fx, I already got x power half minus with x power negative half. For f prime x, I use power rules and I have two terms, first term and second term. After I calculate first term and second term, I plus it, and so I get f prime x, that 1 over 2 square root x plus 1 over 2 x power 3 over 2. For step 2, find, we use function fx, but x is, we change it to a0 and we input the value a0. So we got 7.875. For step 3, we use f prime x function, and we use x0 and we change it to 64. So the answer is 0.063476. For step 4, we just insert the value that we already got. So 7.875 plus with 0.0034766 multiply with negative 0.01. So answer I got is 7.874365. But the answer one only 3 decimal place, so my final answer is 7.874. That's all from me. In conclusion, mastering technique of differentiation requires both a clear understanding of the rules and high attention to detail. Success depends on picking the right rule, such as product, quotient, or chain for complex expression, and accuracy in handling multiply, function, layers, and algebra sign. And lastly, precision during the final simplification to avoid careless errors. For overall, consistent practice is the key to overcoming this common technical challenge.